welcome back to Information Retrieval Lecture Series. So, uh, we shall continue by looking at the definition of information retrieval, and I've highlighted some important terms here. Information retrieval has to do with finding a material. Now, usually we say we're limiting the material in this form to text materials, and those materials that you're finding is of an unstructured nature. What do you mean by unstructured? That is, it's not structured. It's not, for instance, in a relational database that you can say, okay, it has a primary key, it has some attribute, then I can just use the primary key to locate the record and retrieve it. No, you can put it in a structured format like that. It's not it's not that format. So you're trying to find a material from an unstructured document, and you want the material that will be returned to satisfy your information need, and this is coming from a large collections. So now if you look at this definition very well, you will see that if it's coming from just a small collection, maybe few of one, two, or three, wow, you can easily just take each of the document and just read through one or two. Let's say scientific literature, let's say there are just one or two of them. You can just pick them and just quickly read through and trying to see whether they contain the information you're looking for. But when we're talking of hundreds of thousands, how many are you going to read? And unfortunately, it's not all of them that contain your information that you're looking for. So how do we design a system that will help us to be able to quickly locate that particular document that has the information that we need and miss so many, or that can tell us that okay, maybe there's actually no document that contains the information that we need. The truth of the matter is, if there exists a document that contains the information that we need, then it means that we can find that document. But in a billions of documents, it may be absolutely impracticable to manually look through each of the documents to search out for the one that contains the information that we need. And that's what information retrieval systems are meant to help us to do. Another important point is it must satisfy an information need. Now, that in itself is abstract because information needs is dynamic and is ever changing. And somebody's intent for making a search might be different from another person's interest for making a search. And this is complex, and somebody's interest now, let's take the same person, somebody's interest now for making a search evolves over time and is dynamically changing. So we cannot say okay, we can just catch the once we are able to get what the person needs, we can just put a catch, and every time we know the person we request for the same thing. This is not necessarily true. People's need, people information need always are always changing, and so the system also has to adapt to these changes in the information need. All right. So there are other definitions. Uh, this definition says IR deals with adequately identifying information content of documentary data. So you may have a particular scientific literature and you want to try to classify or do what you call topic modeling and try to retrieve from the scientific literature those that deal with a particular event or deal with a particular recipe extraction, for instance, in the field of nanomaterials or in medical diagnosis. You want to retrieve a document that has to do with cancer related, skin cancer or breast cancer or cervical cancer. So all those things are things that could be information, being able to adequately, correctly identifying the information content. Another definition says processing files of records and requests for information, identify and retrieve from the files certain record in response to information requests. Those are all being captured in what I said earlier. So the retrieval of a particular records depends on similarity between the records and the query, and that's very essential. But then, as we see, you also see that many a time people have A in mind, but they are actually putting B as their query, and they are expecting the system to return results of A. I hope you get what I'm trying to say. Sometimes, let's say somebody wants to call John and is calling Jane and is expecting John to answer. You see that the information retrieval system in itself it's already confused, because the person's information need is is to get the attention of John, but the person himself has erroneously input a wrong query by calling Jane, and the person will be getting Jane as output, but then he will say, no, this system is not working, I expect John. But there's no way the system can figure out. How can the system figure out that this person does not really want Jane, the person wants John, even though the query contains Jane? So this happens a lot in information retrieval. So how do you retrieve particular records depends on this similarity between the records and the query. So the query and the existing record, you want to say how close are the records with the query, and so that you can return. Then even the records that are close to the queries, in what order should we return them? So how do we have measure the hierarchy, the ranks of return? Because when you put in a search word in a search engine, there could be multiple records that are relevant, but then which one should we present first, or which ones? Because definitely if we have like 50 that match, we cannot expect the reader to be reading all the 50 to be able to be satisfied. We have to order them in such a way that the first few, top maybe 1, 2, 3, the readers can get what is interested in. So this happens by comparing the values of certain attributes in the queries to records and the information requests. So we live in a search society. People are always searching for things, searching for wedding gown, searching for household materials, searching for kind of cars, searching for kind of phones, searching for a kind of software, searching for a kind of text material, searching for a kind of literature. People are always having information need, and this is ever growing. So we believe that almost everything is out there, and we just need to get the information. People are searching for job, they are job search. People are searching for medical diagnosis. So we search for everything, and we live in a search world. So the field of information retrieval is a very important field, because it directly have impact on consumers on a daily basis. So then, how do we use machine learning in information retrieval? Now let's quickly explain what machine learning is. Machine learning is a subfield of artificial intelligence whereby machines learn from experience, that is from data, not by hard coding, like you have to do a kind of procedural programming. So now we can make use of machine learning in information retrieval such that we give the machine a lot and lot of examples of past. Then the machine can learn a pattern from those examples and use it to predict the future. So we have our information in bit and byte. So the machine can take in the information and use it to learn. and this can come in the form of supervised learning or unsupervised learning. Machine learning in some of the higher directions. Now, basically, we have text clustering, we have text categorization, we have learning for information extraction, and text mining. Let's briefly look at some of this. Text clustering, for instance, you are trying to cluster text clustering. You're trying to cluster the information retrieval query result. So if you have the results from a IR system, you may cluster them based on geographical location. You may cluster them based on what? Clustering just means grouping them based on date. You may cluster them based on the vendors. So yeah, automatic formulation of hierarchies, and that is what I said before, based on importance, based on urgency. How do you rank them? Then you also talk about text categorization. So you have automatic hierarchical classification. That is, you want to put them in categories. Okay, this one deals with political news. This one deals with sport news. This one is educational news. And you want to also adaptively filter. That is, you want to dynamically filter the system for recommendation, like in the e-commerce. Then you have automated spam filtering, and we receive a lot of emails, and some of which are actually spams, unsolicited emails, and you want your email system to be able to spot out and say, okay, I know that this email is spam, and just save you the time of having to recognize it as spam and deleting it yourself. So what does the email system do? It does that for you automatically without your knowledge. As the email is coming, it pushes it into spam. So that is trying to categorize those emails as either spam and not spam. Learning for information extraction, and that is another important one. We talk about information retrieval, which you can see it as the high level of trying to retrieve a particular document. But then if you retrieve a document, you may want to retrieve from that document, you may want to extract what you call recipe, maybe a step-by-step process of doing a diagnosis, or a step-by-step process of performing an experiment. And that's all you need. So you may want your system to be able to give you a steps of doing those things. That's information extraction. And you may want to do text mining. So there are a lot of examples of information retrieval systems that have been developed that are out there. Most universities' library has a catalog for which they'll be able to categorize the books into different shelves, into different fields of study, and how you can actually access them by using a kind of search keyword, the title and the author. You have some text-based that you have in Google, search engine, the Bing, and the DuckDuckGo, and you can search by keywords, and you have limited search using queries in natural language. You also have some question answering system like start ask. Okay, you can search in natural language. Okay, you can ask Independence Day of countries, and you have cross language information retrieval. That is, in which case you have multiple languages: Spanish, French, German. So this is an example of IR system. It's a web search system. That's DuckDuckGo. This is a question answering system. So you can just key in a question, and this can bring out answers to those questions. So some of the IR system links, if you want to search for images, you can use Big Search, and that's interesting. You have an image you want to search for, maybe you want to know the name of the image, and you may just upload the image and it will give you the name or a similar image. Question answering system. You can also have a music retrieval for lovers of music. So, information retrieval in summary, you do a lot of activity. We try to process the information, the document that we have, which serves as our input. We try to index them in such a way that it will be easy to efficiently retrieve them when we need them. We retrieve the textual document, and this textual document will come in different formats. We have some text, we have PDF, we have words. So first of all, our major concern is to return relevant documents to a user query. If we return a document and it's not of benefit to the user, then the IR system has no value, has no usefulness. So secondly, we are retrieving from a large set of documents and it has to be efficient. If we have to wait for a week before our IR system returns result, then that will not be too good. So thank you for listening and hope to see you in the next one. Thank you.